So I've decided to do a little Unit 8 review video since we didn't have time in class. So this is a quick little review for your midterm. Quick being, this will probably end up being 20 minutes, so we will see. Unit 8 was about sequences and series, so the major ones we talked about were arithmetic and geometric. We said with arithmetic you think adding, and with geometric you think multiplying. So if we look at these two sequences and just determining the difference, the first one looks like we're adding by 5 each time. So that means this is an arithmetic sequence with a common difference of 5. The second one looks like we're multiplying by -3 each time. So this is a geometric sequence with a common ratio of -3. So if I start with just talking about arithmetic sequences, there are two ways we can express them: recursively and explicitly. Recursively, you have to memorize. Explicitly, we will give you. So if I look at this, I'm seeing each time it looks like I'm going up by 6. So the common difference is 6. So starting with an explicit formula, a sub n is equal to the first term, which is 8, plus n minus 1 times d, which is 6. Sometimes you would simplify this, like if it was a multiple choice, that might not be one of the answers, so just be aware, but that is a formula. Recursively, you always need to say what the first term is, so 8. And then I always read this as, if you want the next term, you have to read it as the previous term plus whatever you're doing each time. I'm adding 6. So if I want the next term, I'm going to take the previous term and add 6. I took the previous term, added 6, that's what gave me 14. So just a little context here, a Greek theater has 30 seats in the first row and the center section of the center section. Each row behind the first row gains 2 additional seats. So that means you're going up by 2. So our first term is 30. If I want the next row in the sequence, I have to take the previous term and add 2. So that's a recursive formula for that sequence. So just using this from above. If I want an explicit formula, just using this formula, I'm going to take the first term plus n minus 1 and multiply it by 2. So if I want the 50th, how many seats would be in the 50th row, I'm always going to use the explicit formula and just evaluate it at 50. So in my calculator, I can do 30 times 49, or sorry, 30 plus, what am I doing? 30 plus 49 times 2, and I get 128. There will be 128 seats in the 50th row. Now, what you should notice each time is that an arithmetic sequence follows a linear pattern. So that means the common difference is equal to the slope. So let's just say, for example, this one up here. If I were to simplify this, this is 30 plus 2n minus 2, right? So that's 2n plus 28. This 2n, the 2 corresponds to the slope of that line. Do you see how that corresponds then to the common difference? So in this next problem, I have the 4th term and the 7th term, and I want a formula to represent this sequence, which I know the formula for the nth term is this. That means I'm going to need the first term and the common difference. I can find the common difference right away because they gave me 2 points or 2 terms in the sequence. So if you think of a sub 4 equals 32 and a sub 7 equals 68, this is like coordinate points. 4, 32. The 4th term is 32. 7, 68. The 7th term is 68. If I find the slope of those 2 points, that'll give me the common difference. So 68 minus 32 over 7 minus 4. So 36 divided by 3, which is 12. So I'm going to plug that in for D. Now, I don't know the first term yet, but I'm going to algebraically find it. So give me 1 second here. Okay, I don't know the first term, but I do have a lot of information. They gave me the 7th term. They also gave me the 4th term. I know a sub 7 is 68. So because of that, that corresponds to the 7th term, so 7 equals n. I can plug in enough information then to solve for a sub 1. So just by cleaning this up a little bit, I have 68 is equal to a sub 1 plus 6 times 12, so 72. And then if I subtract 72 from both sides, a sub 1 equals -4. So coming back to the original problem, if I want a formula for the nth term, a sub n is equal to the first term plus n minus 1 times the common difference of 12. And there you go. So along those same lines, if you're given a pattern and I'm saying like this is a sequence, see how it looks like a line has the pattern of a line? That means this is an arithmetic sequence. Now I know I didn't tell you that, or I did tell you that. If I didn't, that's how you would do it. If it looked more exponential, then it would be a geometric sequence. Well, anyway, if I want to write a formula to model this, the first term is 4, the second term is 6, and the third term is 8, and so on. If I use the explicit formula and just plug in, the first term is 4. The common difference looks like it's 2, because I'm going up by 2 each time. Okay, so if you know the common difference of an arithmetic sequence is -3, and the value of the first term is 17, and the last term is -40, how many terms are there in the sequence? We're going to use the explicit formula to help us solve this. Okay, they gave me the first term. They said the common difference is -3. I don't know how many terms there are in the sequence, so that's n, so that's why I left it as n. But they did tell me the last term is -40, so I'm going to plug that in for a sub n. So I'm essentially finding what n value, or what n number in the sequence corresponds to -40. Okay, so notice how when I wrote -3, I wrote parentheses around it. Make sure you do that, because sometimes students will do this. Oops. And then that looks like -3, and then they get it wrong. So mathematically, it's incorrect looking, and secondly, it might mess you up. So just make sure you use parentheses. So if I want to solve for n here, clean this up a little bit. This is -3n plus 3. So 17 plus 3 is 20, and then I can subtract. So -60 is equal to -3n. So n equals 20. So there are 20 terms in the sequence. So if I want the value of the 9th term, I would just go back to my explicit formula. So 17 plus n minus 1 times -3, and I would just evaluate it at 9. So you're plugging 9 in for n, and you guys can do that. So that's all arithmetic. Geometric. I give you a sequence, 4, 8, 16, 32, 64. I am multiplying by 2 each time. So that's my common ratio. Here's your explicit formula, which is again given to you on your reference sheet. A sub n is equal to the first term times the common ratio. Should I write it like this? 4 times the common ratio raised to the n minus 1. Recursively, the first term, which I always have to state, is 4. If I want the next term, I have to take the previous term and multiply by 2. So if I wanted the 15th term in the sequence, I would just take the explicit formula and evaluate it, which then you just plug it in your calculator, and that would give you the 15th term. Okay, now these ones are tricky. The explicit formula for a geometric sequence is this. Notice how it's not in the form a sub 1 times r to the n minus 1. It's got a 4n out here. So the first term is not going to be 144. If I want the first term, I'm really just asking you what is a sub 1. So just evaluate it. A sub 1 is equal to 144 times 1/2 to the 4 times 1. So if I go to my calculator, whoops, I didn't want that one. Oh, thank you. This one, here we go. 144 times 1/2 to 4 essentially, 9. Okay, so the first term is 9, so not 144. What's the common ratio? Again, it's not 1/2 because it's not in the explicit form that you're familiar with. So I have to look at this 1/2 to raise to the 4n and do a little manipulating. I'm going to bring the 4 in, leave the n on the outside. So now it's of the form a times b to the x, just like a geometric sequence or just like an exponential function. So what this simplifies to, that's your common ratio. So 1/2 raised to the 4th is 1/16. So then if I were to put this together and do a recursive formula, the first term is 9. And if I want the next term in the sequence, I have to take the previous term and multiply by 1/16. Okay, so, all right, come on, move for me. Trying to move it to the next row and it won't move, come on. Hate when that happens. Ah, there you go, finally. All right, so here we are. What is the common ratio of a geometric sequence where the second term is 40 and the fifth term is 625/8? I like to map these out. So the second term, third term, fourth term, fifth term. They told me the second term is 40 and the fifth term is 625/8. Now in a geometric sequence, you are simply multiplying by a common ratio each time to get to the next term. So like if I want term 3, I would take 40 and multiply by r. So technically that would be 40r. Then I'd multiply by r again, and that would be 40r squared. And then again would be 40r cubed. So if I take 40 and multiply by r 1, 2, 3 times, 40r cubed is representative of what 625/8 is. So now I want to solve for r. That's my common ratio. So 625 divided by 8, then divided by 40, gives me 125/64. When I take the cube root of both sides, r is going to equal 5/4. Sigma notation. Sigma just means sum. So it's a big Greek letter that means sum. So you are going to find the sum of the terms where you have 3n squared between 2 and 5. I start by plugging 2 in for n. So 3 times 2 squared. Plus, that's where the sum comes in. Next integer value, 3 times 3 squared. Plus 3 times 4 squared. Plus 3 times 5 squared. And I stop at 5 because that's my n value at the top of the sigma. Now at the end of the day, they still want you then to take that sum and multiply by 2. So you just evaluate that in your calculator, whatever that may be, but this is the expanded then form of the sigma notation. Then if I give you a sequence and I want the sigma notation, just look at it and be like, is this arithmetic or geometric or what? In this case, it doesn't look like it's arithmetic because I'm not adding something each time. It looks like I could be multiplying by something each time. The common ratio will be 12 divided by 18, or if I divide both the top and the bottom by 6, that's 2/3. So if I multiply 18 by 2/3, I'll get 12. 12 times 2/3, I'll get 8, and so forth. So you could double check me on that, but our common ratio is 2/3. So here's how I can always write a sigma if it's either arithmetic or geometric, and in this case it's geometric. I can write the explicit formula inside here and then just index it a certain way and it'll work. So the explicit formula for a geometric sequence is the first term times the common ratio raised to the n minus 1. I can start my indexing at n equals 1. This is my start value, because if you think you put 1 in for n, that creates a 0. So 18 times 2/3 to the 0, well, that's just 1. 18 times 1 is 18, and that's your first term. You end it at however many terms you have. So this was 1, 2, 3, 4, 5, 6. So end it at 6. Now just to show you that I did this right, pulling up my calculator again, if I go to my y equals and I plug in 18 times 2/3 to the n minus 1, or x minus 1, I should get these terms. Okay, and there you have it. So when n equals 1, I got 18. When n equals 2, I got 12. When n equals 3, I get 8, and so forth. So this did work. All right, so geometric series. This is just the sum of a geometric sequence. This formula is given to you on your reference sheet. Use the formula to find the sum of the first 6 terms of this sequence. So first thing you have to look at is, what's the common ratio? Which, it's not obvious at first, but 24 divided by 16 will give me the common ratio, because it's the term divided by the term before it. So 16 divided by 24, oh wait, no, 24 divided by 16. So 1.5. So our common ratio is 1.5. So if I want the sum of the first 6 terms, I need to plug in the first term minus the first term times the common ratio raised to the 6, because that's what n is, all over 1 minus 1.5, the common ratio. Now I just use my calculator. So 16 minus 16 times 1.5 to the 6. I would evaluate that numerator first, then take that and divide by 1 minus 1.5. So 332.5. And that's your sum. Use the explicit formula to find how many terms there are in the sequence, and then calculate the sum of the series. Okay, so it looks like I have a geometric sequence because I'm multiplying by 4 each time. So the explicit formula for a geometric sequence is this. I know the first term is 3 and the common ratio is 4. I don't know how many terms there are in the sequence, but I do know that the nth term is 196,608. So now I have to solve for, now I have to solve for n. Okay, so like we did in Unit 7, first thing we should do is divide everything by 3. So 65536. Oops, 4. Now I should try to get a common base. So I'm going to go to my calculator and look at just 4 to the x in my y equals, because this will help speed up my thought process rather than guessing and checking. So if I look at my table of values, I'm going to look for this number. There it is. So 4 to the 8th power will give me 65536. Now that my bases are the same, I could ignore them. So 8 is equal to n minus 1, or n equals 9. So there are 9 terms in this geometric sequence. I want to find the sum of those 9. So at this point, you're now just plugging in the first term minus the first term times the common ratio raised to the 9, all over 1 minus the common ratio of 4. And just like the one before it, just evaluate that in your calculator. How many terms are there in the geometric series if the first term is 2, the ratio is 3, and the sum of the series is 242? So S sub n is equal to a sub 1 minus a sub 1 times r to the n all over 1 minus r. They gave me the first term is 2. Common ratio is 3. I don't know how many terms there are. That's n, so I have to leave it as n. Divided by 1 minus 3, which is the common ratio. And they told me the sum is 242. So I plugged in everything based on what they told me. Now, the only thing I don't know is n. So if I clean this up a little bit, 1 minus 3 is negative 2. So I'll just, rather than take up space, I'll just rewrite that as negative 2. What I can do is put this over 1 on the left side and then cross multiply. So negative 484 is equal to 2 minus 2 times 3 to the n. Subtract 2 from both sides, so negative 486 is equal to negative 2 times 3 to the n. I'll divide both sides by negative 2, which is what you guys tend to forget first, so make sure you're dividing by negative 2. So I get 243 is equal to 3 to the n. So now, just like the problem before it, let's see, can we get a common base of 3? So I can go back to my y equals and change that to a 3 and look at my table. And look at that, there's 243. So it looks like 3 to the 5th power gives me 243. Just to show you again, 3 to the 5th, let's see, 243. So once the bases are the same, I can ignore them. So n is 5. There are 5 terms in a sequence with those conditions that sum to 243. All right, last problem I'll do. Particular sequence is defined recursively as f of 0 is 1, f of 1 is 1. And if I want to find f of 4, just follow the pattern here. If you want f of 4, you want f of n, which is 1 less than the one before it. So that's f of 3. Minus 4 times, then take one more away, f of 2. So I'll read this as, if you want the next term, you need the previous term minus 4 times the second previous term. They only gave me the first 2, so I need to work my way up to get f of 4, because that's how a recursive sequence works. It's always built on the previous terms. So that means f of 2 is equal to f of 1 minus 4 times f of 0. So the previous term, the second previous term. I know f of 1 is 1, and same with f of 0. So 1 minus 4 is negative 3. If I want f of 3, I'm going to take the term before it, so negative 3 minus 4 times the term before that, which is 1. So negative 7. So then lastly, f of 4 is going to be the term before it, minus 4 times the term before that. So that's negative 7 plus 12, which is 5. Alright, so I'm done. I'm not going to do the mortgage problem, but it looks like I ended at 24 minutes, so I estimated 20. I was close. I went over by 4, but close enough. Good luck studying.